Laboratory equipment. When it comes to ensuring the validity of results in a laboratory, equipment plays a central role. The ISO IEC 17025 establishes the requirements that a laboratory must meet in terms of access, control, calibration, and maintenance of its equipment. In the following, we will explore these requirements in detail, integrating practical examples to facilitate understanding. Access to equipment. Having what is necessary for each task. To begin with, the standard states that the laboratory must have access to all the equipment necessary for the proper performance of its activities. This includes not only measuring instruments, but also software, measurement standards, reference materials, reagents, and consumables. The idea is that anything that can influence the results should be available and in optimal conditions. For example, in a laboratory performing chemical analysis, having a calibrated spectrophotometer is essential to obtain valid and reliable measurements of the concentration of substances in a sample. However, this equipment is not useful if the correct reagents or software to properly process the data obtained are not available. Therefore, the standard stresses the importance of comprehensive access to all these resources. Control over external equipment. Maintaining consistent standards. Sometimes, a laboratory may need to use equipment that is not under its permanent control, such as when certain tests are outsourced or specialized equipment is rented. In these cases, it is critical to ensure that this equipment meets the same requirements as the laboratory's own equipment. This means verifying that external equipment is also properly calibrated and maintained to ensure that results are consistent and valid. Imagine a laboratory that needs to perform a specific test on equipment it does not own and decides to rent it. Before using it, the laboratory must confirm that the equipment meets accuracy requirements and that its condition is suitable for reliable measurements. This control ensures that laboratory standards are not compromised, even when external resources are used. Equipment handling procedures. Taking care of every detail. The laboratory should establish and follow clear procedures for handling, transporting, storing, using, and maintaining equipment. These procedures are vital to avoid contamination, deterioration, or malfunction of equipment, which could affect test results. For example, if a laboratory uses a high-accuracy analytical balance, it must have an established procedure for regular calibration, cleaning, and storage in a place protected from vibration and sudden temperature changes. This care ensures that the balance maintains its accuracy and prolongs its useful life. Equipment verification, ensuring accuracy right from the start. Before equipment is installed or reinstalled for use, the laboratory must verify that it meets the specified requirements. This is crucial to ensure that the equipment is ready to provide valid results right out of the box. Suppose a laboratory acquires a new gas chromatograph. Before starting to use it for analysis, the technical staff must verify that all specifications, such as measurement accuracy and the ability to separate compounds, are within acceptable limits. Only after this verification, the equipment is put into service. Accuracy and uncertainty. Keys to reliable measurement. Measurement equipment must be capable of achieving the accuracy and measurement uncertainty required to provide valid results. In addition, this equipment must be calibrated when its accuracy or uncertainty may affect the validity of the results or when metrological traceability needs to be established. For example, if a laboratory uses a balance to measure the mass of samples, it must ensure that the balance can measure with the required accuracy. If the balance is not calibrated correctly, even small deviations could lead to significant errors in the final results, especially in analyses where high accuracy is required. Calibration program, maintaining reliability. To ensure that measurement equipment continues to provide reliable results, the laboratory should establish a calibration program. This program should be reviewed and adjusted as necessary to maintain confidence in the calibration status of the equipment. Imagine a laboratory that performs environmental analysis. The instruments used, such as mercury analyzers, require periodic calibration. The calibration program ensures that this equipment continues to operate within the parameters necessary to provide valid results. Identification and management of defective equipment, safety in use. All equipment requiring calibration should be labeled or identified so that users can easily verify its condition. In addition, if equipment is found to be defective, it should be taken out of service until it has been verified that it is functioning properly. For example, if during an internal audit it is discovered that a thermometer used to check incubator temperatures does not meet specifications, it should be tagged out of service and removed immediately. Then, an assessment should be made as to whether previous results involving that thermometer are affected and whether any retesting is necessary. Intermediate checks and data update. Maintaining accuracy. Intermediate checks are necessary to ensure that the equipment continues to function correctly between calibrations. In addition, any updates to reference values or correction factors must be implemented to ensure that the results remain valid. In a materials analysis laboratory, for example, it is common for intermediate checks to be performed on measurement equipment as part of daily quality control. These checks help to identify potential problems before they affect customer results. Equipment logging and maintenance. Detailed documentation. Finally, detailed records should be kept for all equipment that may influence laboratory activities. These records include equipment identification, including software and firmware version, manufacturer's name, type identification, and serial number or other unique identification, evidence of verification that the equipment meets specified requirements, current location, dates of calibration, calibration results, adjustments, acceptance criteria, and date of next calibration, and the date of the next calibration or calibration interval. Documentation of reference materials, results, acceptance criteria, relevant dates, and validity period. The maintenance plan and maintenance carried out to date, where relevant to the performance of the equipment. Details of any damage, malfunction, modification, or repair carried out to the equipment. For example, a laboratory that performs quality testing on pharmaceutical products will keep a complete record of every piece of equipment, from its acquisition to its last calibration and any repairs made. This level of detail ensures that the laboratory can track down and fix any equipment-related problems quickly, while maintaining the quality of the results. Conclusion. ISO IEC 17025 highlights the importance of having rigorous control over the equipment used in a laboratory. From ensuring access to the necessary equipment to maintaining a calibration program and recording all details related to use and maintenance. Each aspect is crucial to ensuring the validity of results. A laboratory that manages its equipment with care not only meets regulatory requirements, but also protects its reputation and the confidence of its customers. Well-maintained equipment is the foundation on which accuracy and reliability are built, ensuring that each result is a true reflection of the quality of the work performed.